Hi, I'm Matt Mitchell. This is a short tutorial on some of the work in progress for FLUX Manage. Although we're focusing on the FLUX Manage UI, the key component is behind the scenes. FLUX Manage stores the live details of every sequence on the system. It stores everything interesting about a sequence, all the metadata, and supports a fast query system. The FLUX Manage UI is a drop-down system selector and a folder view, which defaults to the top of the system, where we could drill down into subfolders. In the lower preview panel, we've thumbnails for every sequence below our selected folder. Since we've chosen the root point of our drive, we have 9,467 sequences and just over 4,000 non-image files, such as text files and edit lists. The thumbnails in this view are generated on the fly and are cached. The Metadata Panel on the upper right shows all the extracted metadata for the selected sequence. The Operator Panel below it has a set of operators that we can apply to our set of sequences. The red elements are filters, the turquoise moderators, and the green are for sorting. We can drag these operators across and apply them to the set of sequences. I'll do that in a second. Final panel at the lower right is the shelf for storing saved results. In our preview panel, we can choose to show a selection of the detail of the metadata for each sequence, such as the name or the encoding. I tend to turn that off, but it's all available if you need to see it. To apply a filter, we just choose it and drag it across to the preview panel. We'll choose a sequence length filter. As we drag it, we get a new tab created with an object that represents the selected folder. We've dropped our sequence length filter onto this, and we're going to filter for sequences that are longer than 100 frames. That filter operation gives us a set of 3,323 sequences, about 1/3 of our total set. And as we scroll through them and look at the detail, we can see that the duration is longer than 100 frames. They're in a random order and they're mixed in with audio tracks. We have a Has Audio filter, so we can find that from our filter panel and drag it across and add it to the query. So now we're looking at sequences that are longer than 100 frames that have audio. But in fact, what we might want to do is just look for sequences that don't have audio. So we can invert the sense of the filter. This will show us just sequences longer than 100 frames that don't have audio. At this point, it might be useful to sort them into an order. So we can drag another sorting operator over onto our set, and we're sorting now by length, duration, with the shortest first. If we invert that, we can sort by longest first, and we can see that this particular one has 98,900 frames. We can flip the preview panel into a detailed list view, and that shows all the attributes and metadata in a more compact format. We can see that they're sorted into duration. All of this data has come from the FLUX Manage service. The file system has not been interrogated at all by our queries. Because we already know everything about the sequences on our system, we can very easily look for typically difficult attributes. We know the timecode, for example, so we can search our large sequence set for a particular timecode and see the results returned immediately. This can happen because we already hold the correct timecode ranges for every sequence. We don't have to take the time to look for them on the file system. Okay, so we've seen some basics. Now let's do something more useful. I'm going to drag across a folder name match filter and look for folders that match Doctor Who. That gives me 144 sequences on my file system. I can pull up a player and play through any sequence to check it's the right material. I can drag all those sequences down onto the shelf and save it for reference. I'll call it Doctor Who material. That's everything that I have on my file system that's in the matching folder name, wherever it may be. I can now bring up a Job Manager panel that shows my Doctor Who job with 3 scenes in it. At the lower left is a draggable object that represents the scene or job. I'll drag the job down to create a new tab that contains the material that's used in that job, i.e. in all 3 scenes. We've stripped all the grades out, removed duplicates, and just have a set of the raw reference material. This gives us 44 sequences, 1,991 frames. I can add a little bit more to each of those sequences where it's available by adding 10 frame handles, just in case the edit changes slightly. This gives me 2,060 frames. That gives me the material that we're likely to need to use to finish the job. I can drag that down onto the shelf and rename it. In fact, anything that's on the shelf can be dragged back to create a new tab containing that set of results. Now what we want to do is take the sequences that we're actually using, subtract it from the sequences that are on the file system. So we do a set complement or accept operation to remove the smaller set from the larger. and we see that we are now down to 100 sequences. This is the material that's on the file system, but it's not actually being used in this particular job. I could do another operation on these sequences. I could remove proxies if there were any. In this instance, I'm going to sort by duration. These are the sequences that we do no longer need to keep. This is a quick way to review and remove unwanted material. Another thing that we could do is some consistency checks. In this example, I'm going to look for sequences that are in the incorrect resolution folder. I drag this filter across, and that identifies the sequences that we're looking for, 3 in this instance. This one, for example, is 720 by 576, but it's currently in a folder that's much larger. It doesn't belong there, and it would be an embarrassment if we supplied it to a client. We can do this check quickly because all we're doing is examining sets of data that do not require file system access. In the metadata panel, we have draggable objects for all the key value pairs. For example, we can drag the encoding of this DNxHD sequence filter, and I can see that I have 123 sequences of similar material, or I could remove that and look for a particular file name. Let's look for sequences that match R3D. This shows my red material. I can filter that by the sensor type, in this case Mysterium S35. That gives me 188 sequences, and if I invert it, I can see other sensor types such as Mysterium X S35. If I add that, I can now be sure that everything matches those sensors. I could drag across this tape name and AND it with the existing query. Now I just have the one sequence, because I only have one sequence with that tape name that's in red. If I remove the other filter operators, I can be sure that I only have one sequence that matches the tape name on my whole system. You can see how conform would be improved by knowing everything about a sequence without accessing the file system. We can combine arbitrary numbers of sets of data from the shelf. So I'm going to add 2 sets of data. I'm going to add a third one now, and you can see how they build up graphically. I've now got 145 sequences, which I could feed into another process via the option to export it as XML. Take a look at the text just below the filter result bar at the top of the panel. That text changes as we modify the query. The text is actually the query that's running in a language called FLUX. This language is a scripting language that interfaces directly with the FLUX Manage service. If you go back and watch the tutorial again, you'll see that script alter as we perform groupings and filter operations. All of the functions we've performed in the UI can be done with a scripting language, and I'll be covering this in a subsequent tutorial, along with submission of renderings to the background task manager, the XML interface, and support for customer-specific metadata.